In question 10, curves with equations y equals to 2x power half plus 1 and y equals to half x squared minus x plus 1 intersect at A and B as shown. In part A, we have to find the area of the region between the two curves. Now, to find the area of the region between the two curves, first we'll find the area under the curve with the equation y equals to 2x power half plus 1. Then find the area below the curve for which the equation is y equals to half x squared minus x plus 1, and then subtract the two areas. So area in this case will be equals to, in this case, the limits will now be 4 and 0. So this will be 4 and 0. The equation for the curve, which upper curve is 2x into power 1 upon 2 plus 1, and we subtract it from the curve with the equation half x squared minus x plus 1. So integrating 2x to the power half, that will become 2x to the power 3 upon 2 divided by 3 upon 2 plus 1, and integrating 1 will become x. And in the second case, integrating x squared will become x cube and will divide by the new power. So dividing by 3 will become 3 times 2, 6, minus integrating x, that will become x squared upon 2, and integrating 1, that will become nx. And this is a 2 up here. Now substituting the limits 4 and 0 in both the cases. So substituting 4 up here, this will become 2 into 4 to the power 3 upon 2 divided by, so this 3 will remain the denominator and this 2 will multiply. So this will be 2 times 2 plus x, so x is 4. And if we substitute x equals to 0 in both of the terms, they will become a 0. So we leave it as it is. Now we'll substitute x equals to 4 into this expression. So this will become 4 cube 64 upon 6 minus 4 square, which is 16 upon 2 plus 4. So 4 to the power 2 or 3 upon 2 becomes an 8, and 8 times 4 will become 32. So this will be 32 upon 3 plus 4 minus 64 upon 6. So this will be minus 64 upon 6 minus minus will make it a plus, and 16 upon 2 is 8, and minus plus is minus, so this will be a minus 4. Simplifying 64 upon 6, that will become 32 upon 3. So 32 upon 3 and minus 32 upon 3 will cancel out. Similarly, 4 and minus 4 will also cancel out. So the final answer for the area between the two curves will be equals to 8. In part B, the acute angle between the two tangents is denoted by alpha. So we have to find the value of alpha. Now, to understand how to find the value between these two tangents, what we must understand is that if a line has a gradient of, let's say, 2, so if the gradient is 2, it means that the y value is 2 and the x value is 1, as gradient is given by y over x, or change of y over change of x. Now, to find the angle it makes with the horizontal line, we can use, if let's say if this angle is alpha, so we can use tan alpha will be equals to opposite over adjacent. So we'll use 2 upon 1 and tan inverse of 2 upon 1 to find the value of alpha. Now, as we have two tangents up here, if we make a horizontal line, first we'll find the angle made by this tangent and then the angle made by this tangent, and then subtract the two angles to find the angle in between. So the two equations that we had for the curves were, so this was y equals to half x squared minus x plus 1. Finding the gradient for the tangent, so this curve represents this tangent. So first we'll find the angle made by this tangent and then find the angle made by the tangent to the curve 2x power half plus 1. And then once we have these two angles that they make with the horizontal, we'll subtract them to find the angle alpha. So the other equation is y equals to 2x to the power 1 upon 2 plus 1. First finding the dy dx, as it will give us the gradient. So dy dx in this case will be 2x upon 2, which will be x, minus, in this case, differentiating x will become 1. And differentiating 1, it becomes a 0. In differentiating the second equation, so multiplying 1 upon 2 by 2, that will become a 1, and decreasing the power by 1. So this will be x to the power minus 1 upon 2 plus 0. And we can write it as 1 upon x to the power 1 upon 2. Now using x equals to 4 as they're intersecting at the point x equals to 4. So the gradient for the first equation will be equals to 4 minus 1, which will be equals to 3. And the gradient for the second tangent will be 1 upon square root of 4, which will be equals to 1 upon 2. Now to find the angle alpha, let's say this was the tangent with the gradient 3. So to find the angle it makes with the horizontal, we can say that this length will be 3 and this length will be 1. So we will use tan inverse of, so tan, let's say this was angle theta. So this will be tan theta will be equals to 3 upon 1. And we'll use tan inverse of 3 to find the angle theta. For the second line, for a second tangent, the gradient is 1 upon 2. So this will mean that this length is 1 and this length is 2, as this is opposite and this length is adjacent. So we'll use minus tan inverse of 1 upon 2 to find that this angle that this tangent makes with the horizontal. And once we find these angles, we'll subtract them to find the angle alpha. So tan inverse of 3 is 71.57. Minus tan inverse of 1 upon 2 is 26.57. Subtracting the two angles, the angle alpha will be equals to 45 degrees.